Welcome to Michael Keating's Yunzo, introduced by some other random person in Africa. It's wonderful to be with you all this evening. We're incredibly privileged and truly hugely grateful to Sam Williams for joining us from Arweave. The topic of this Yunzo has been Web3 communities and tokenomics. And Sam and I thought it would be interesting to go through a conversation that looks not just at tokenomics, but mechanism design more broadly, and looks in particular at this notion of adaptive interacting incentive agents, which has been really championed by the Arweave network. And by looking at some of the deeper mechanism design, then discuss how this kind of work can impact tokens and other things which live towards the application level of the stack. So profit sharing tokens and profit sharing communities is something that we will get to. But as is traditionally the case for this random person in Africa taking over Michael's Yunzo, we're going to go elsewhere first, which is into these meta games that Arweave has put together. So I thought that I would just discuss a little bit of the incredible work that Arweave has done before we kind of get into this notion of tokenomics. And in order to do that, like in the technical paper that Sam and the team have put together, the yellow paper in particular, they say that the long-term success of protocols like HTTP have to do with simplicity and adaptability, and that our mechanisms have to be designed in order to be flexible, right, in terms of the ranking and the exhibiting and the rewarding of prosocial behavior in a network. But they also have to be adaptive because these networks change over time. And so Arweave has this really interesting notion of adaptive interacting incentive agents. And each agent in the game is allowed to implement its own strategy, in which the way that players rank each other, as well as the actions that each of them take, are ranked by other players. So this creates a second order metagame on top of the typical tit-for-tat behavior, which is something that comes from BitTorrent, which we'll speak of now. And this incentive to incentivize each other's behavior sort of moves everybody towards pro-social goals. And in fact, the one place that I wanted to begin, because this is the tokenomics Yunzo, Sam, is that agents interact and rank one another for non-token social rewards. And in that yellow paper, you say there's sort of around data distribution and RQL query prioritization. And in your wiki now, it's more about sort of bandwidth and financial rewards. So what kind of non-token social rewards are used to frame and constrain the metagame that you're playing in the Arweave network?
Well, I gotta say, if you're interested in mechanism design, this is like jumping in at like the 1,000-foot deep sinkhole kind of end of the spectrum. Like, this is very, very complicated to understand properly. Well, it's both incredibly simple and also incredibly, the effects of it are quite profound in some sense. So really, constraints are essentially none. The fascinating thing about the game is that it arrives essentially naturally from human behavior. You have to seed it. Seed the pool with a game of some sort, and we chose essentially optimistic tit-for-tat from BitTorrent, which is this simple game where you say, okay, if you give data to me, I'm going to give data to you, and if we give data to each other at random once every while, then the Nash equilibrium of this game is we essentially all share data frequently with each other, and this was responsible for like a third of the internet's traffic at some point. I think, when I first started talking about this, I think it was probably the most powerful and effective mechanism design deployed in human or computer networks in history. Now I think you could argue Bitcoin has overtaken that. But anyway, nonetheless, it was very, very effective. The interesting part of the system is that, okay, that game is being played by everyone in the same way that in our societies, this is actually maybe easier to understand. In our societies, we're playing the capitalist game in general with modifications, but broadly. Well, nobody is actually enforcing that you play the capitalist game. So we actually kind of got thinking about this thinking about this this set of ideas which led to AIIA, when we were discussing on the random channel via Slack about how humans have ideas about the world, and well, Jung at least says that humans don't have ideas so much as ideas have humans. They're kind of controlled by the ideas. And we were discussing how, you know, in a communist country and in a capitalist country, just in the archetypes, they're both living by different mechanism designs. So what's interesting is you could take a human from each of those places, you can swap them in the societies in which they live, and they might try and continue to play the game. So they might be enforcing the rules of the opposite mechanism design in the opposite country. And in doing so, they would find that there is no consensus, for one. Like if all of the people from all of the countries swapped at the same time, then of course the systems would continue to run as before. So there's no consensus enforcement. But also that it's actually that you can have two people playing two different games, and then the effect of those two games played together is to some extent the meta of the two, the abstraction of the two, if that makes any sense. It's really strange. But yeah, go on.
It's a wonderful part of, I think, something that we've been exploring more broadly in this block is the fact of like non-coercive games are difficult to explain because our language is so deeply set up in order to speak about, look, you're playing with bandwidth, you're playing with financial rewards, you're playing with RQL query prioritization. Even in like my own reading of the yellow paper, I like look for those specific things. Like, what are the things that we can point at and like understand mentally and logically that like I can use as a means of navigating the game space, right? And what you're saying is, it's whatever strategy you want to write, whatever code you can create that will implement these favors is what will drive and contribute to the total sum of like the game being played on the network. You know, so this notion, and it's deeply unintuitive even to people in crypto. It's one of the things that I love about Arweave, Sam, is that strategies are not dictated by consensus rules. You know, the first time that I read this in the Arweave paper, I was just like, hang on, what? Yeah. Because we're all about consensus, you know, and yet like the totality of the rules expressed in this metagame are defined by the sum of each of the individual games that are currently being played. Yes. So this is like, you know, two great effects of this for me. Like there's no need for centrally enforced protocol upgrades. And there's this highly scalable game structure where communication overhead on consensus is virtually like non-existent, right? You don't have to communicate all the time to stay in consensus. This thing of like Bitcoin is worse is better because it's like the kind of design that no purist computer scientist or cryptographer would ever have come up for because it's just so inefficient. It's like, why? And Arweave kind of gets away from that. But one of the questions that I want to ask you is like, you know, BitTorrent, where you take your motivation from and your inspiration from, had this optimistic tit-for-tat algorithm that got overtaken by BitTyrant, and then some people wrote an alternative and improved version. And like BitTorrent is really interesting because it allows clients to maintain these private local scores for other peers. And I'm kind of wondering, you know, in Arweave, like you say that Arweave is able to generalize this from like good use of bandwidth resources to generally prosocial behaviors, and that this has to do primarily with like favors or with responsiveness. Peers rank each other's responsiveness. So can you like explain to us?
Yeah,
how it starts, right? Where it begins.
Right, exactly.
Yeah. So how does Arweave get from like just this game about like good bandwidth to generally prosocial behaviors? Like
right. So I think you can. Okay. So actually, the BitTorrent, BitTyrant, and then the improved version of the BitTorrent optimistic tit-for-tat algorithms is really, really simple as it goes example of this in practice, right? So you started, and the game space was everybody playing the same game, optimistic tit-for-tat, which is essentially what people largely do in Arweave now. Then someone came along, they were like, oh, there's a flaw in that mechanism. Okay, I can change the game. I can make it so that I can leach more data than I am sharing. Okay, cool. So now if you think about the game space, there are two games being played in the same network. So the BitTyrant clients are ranking their peers in one way, and the normal clients are ranking them in another way. And so you can kind of see that now, like if you were to do an analysis of the game, you have to take the superset of the rules of both games. Yeah, so you can kind of see that's where this behavior comes from. And then over time, people came up with an improvement exactly. And as you say, Andy, everyone largely upgraded to the improvement, and now you're back to a single game in the space. But this could happen because there's no consensus. Okay, so in the case of Arweave, I think the key learning was something on top of that. It's the meta behavior of that change in games over time that we were really interested in. And again, we took our inspiration for this from the real world. Like, it does kind of appear that actually the mechanism designs of the real world, there is no consensus, there's no enforcement that everyone in the world plays the same mechanism, right? It does actually appear that over time, the mechanisms are becoming more pro-social, which is pretty interesting. So we started to wonder, well, can we prove that mathematically? That this is the natural tendency of things. And so we realized that the fundamental thing is people have to have a stake in the protocol in our case, but I guess the environment of the game succeeding over a long period. And so when you're an Arweave miner, of course, you're earning Arweave tokens and you have some level of investment in doing that. So you have some amount of incentive to try and make sure that the Arweave protocol succeeds. And so if you have this, you end up with this bizarre, we call it, so we build a simulation of this. We call them biases. So you might believe, you might believe that the world should be one way, that everybody should be playing the game in this way. But you've got a tricky problem, which is actually everyone is playing it in this other way. And if you just start playing unilaterally the game in this way, well, then you might be ranked poorly because the world is this other way, right? It's like if you believe that the world should be more loving and kind, for example, but you live in a capitalist society where everyone is motivated kind of by greed. But if you're the only person playing that new game, you're going to have a problem. And so the question becomes, well, is there an incentive which moves us towards the right game, or towards the expression of the net set of biases of what we believe is the right game over time? And the answer, we think, is basically yes. You are incentivized not to do it yourself necessarily, but to incentivize others to do it. So if another person takes this more loving and kind route in society, then there is some net positive for you of this person doing this better mechanism, essentially. Okay, so now you are incentivized some tiny, tiny, tiny fraction, tiny amount, to reward that person for displaying that behavior positively. And so when you do, you create an incentive for that person to display that behavior. Okay, and now if everyone in the network, even if the behavior is, if the game type is over here, if everybody has a bias that says, we think the game, the pro-social version of the game that is better for the environment is over here, then now we have at least some reasonable incentive, well summed across all of the players of the game, to incentivize others to act in that way. An example in the Arweave network is, and we give this in the yellow paper, I think. Okay, there are these nodes in the Arweave network which can optionally run an IPFS bridge. So they can pin data that's inside Arweave on an IPFS node locally and make it available there. This is a pro-social behavior, because if we are all incentivized around the Arweave token, it's evidently more useful if it has more features, right? But the thing is that there's no, because of the way IPFS works, there's no easy way to enforce consensus that someone's actually pinning the data in IPFS. Okay, so I can say, well, I can check if Andy or Greg, for example, are running an IPFS node on their machine. I can ping them, and I can just say, okay, I'll apportion more of my bandwidth, for example, just a tiny bit more, to Greg if he's running an IPFS node, and away from Andy if he's not, something like that. And so you can kind of see that there's this, it's weird because it's a second order effect, but an incentive to incentivize others to do pro-social things. And And as a result of that kind of recursion, you end up actually doing prosocial things slowly, eventually yourself. Yeah, I forget how we started this section, but hopefully that is a reasonable explanation of how the system works.
Absolutely, absolutely. It's wonderful that we get lost in our own feedback loops as we talk second order cybernetics. And if you're interested in this kind of stuff, it begins with Norbert Wiener, who wrote some really wonderful books and has been extended, you know, wonderfully in modern times. And Arweave is a really great example of this. But Sam, I want to pick you up on one particular aspect of this, which is the simulations that you ran in that yellow paper, and which have to do with your sort of internal agent characteristics and the biases that you talked to. So in the simulation that you ran in the yellow paper, you say that over a long enough time period, the internal agent characteristics tend toward the common biases in the agent set. And, you know, that's a wonderful thing in the context of like running an IPFS bridge and displaying these kind of prosocial behaviors. But it's not such a wonderful thing if people are not
wrong.
You know, yeah, exactly. That
yes.
The game, the structure that you said of reality is over here, and you want to shift it to over here. Over here can be like, yes, like a net positive thing, but it can also like not be, and we're, you know, kind of not so wonderful at deciding that. And I wonder, like, just for the people on this call in particular, who are all kind of like engineers, creators, coders, programmers, gamers, this kind of stuff. How did you think about engineering the right kind of initial conditions, the right kind of initial set of biases? You know, how did you think about that?
This was actually fairly obvious to us. So the first agent was called Wildfire, and it was so because kind of visualized how the blocks and transactions in the network should spread. And we realized that actually there's something very simple, which is the nodes that you can speak to quickest are the nodes you should generally propagate blocks and transactions to. And if you do, you get this effect where the data moves around the world geographically across the internet. Well, not quite geographically, but close to geographically biased by the speed of the interlinks, right? So it's internet geographically. Rather than if you pick random nodes, right? And then if, you know, it's fairly slow to distribute blocks to people that might be very close to you. This is actually very useful because it's powerful for routing around things like the Great Firewall, which actually is a problem in the Arweave network now. Like the link is slow across this thing. But of course, because of the way that the simple ranking algorithm works, it finds the fastest route, essentially, in a fairly effective way. Yeah, so there was that. And we also knew, like, there was this big question of how do you distribute data in the network? We don't want to have to, no storage project that I know of has produced a decentralized storage project, has produced a functional proof of transfer protocol that doesn't require double synchronization. So AIIA has this system, which is, so Filecoin, just like you have a retrieval contract, which you negotiate at the end of the storage term, or whenever you actually want to access the data. So you don't get a guaranteed price up front, and they don't do any verification that the transfer actually happened, like none. And the reason for that is it's very, very hard to do proof of transfer on the internet. AIIA did, but the way that they did this is this kind of, it's kind of elegant from a computer science perspective, but very, very inefficient route of like, okay, so if you send me a chunk, so we make a retrieval contract, and then you send me a chunk and I sign it, and then I send you back the signature, and you send me the next chunk to sign back the signature. Now you've got this really long list of signatures, and if I want to actually get my file, I have to send you back the signatures so that you can prove to the chain, hey, actually, look, this is how much of the transfer already happened. But this has a big problem, which is that, you know, if you're in South Africa, I'm in New York, right? Then we have this latency that every single chunk that we want to do, which is super, super slow. The only distributed protocol that got this right was BitTorrent. They have this really elegant system that just says, well, yeah, if I share data with you, you share data with me, and then we occasionally share data with each other, and boom, now we have a Nash equilibrium where we're maximizing data distribution in the network. So it seemed like the right solution to the problem. One way to think about Arweave is it's like a big, ever-growing BitTorrent swarm with incentives to pay for people to seed, essentially.
Yeah, may torrents never be down.
Right.
That's so wonderful. Right. Wonderful. So I also, the other thing that I kind of want to pick up on this is that, you know, it's really interesting to me that in our gaming module and a lot of the things that we've kind of talked about have to do with this notion of different kinds of, or different means of ranking players and different means of measuring certain kinds of actions within games in order to encourage pro-social behavior. And one of the critical points that comes out of that is that, you know, we're really no good at measuring, you know, deeply pro-social behavior. And what we can kind of aim for best is these proxies, like time spent together, time spent talking positively, time spent in high emotional situations that are potentially very dangerous, and all of these kinds of things. But it's fascinating because as soon as you start showing those to players, they end up optimizing for that instead of like the actual pro-social behavior that you're trying to like create in your game. And you see this kind of thing in your own setup in Arweave, right? It's really fascinating that, like, you say rational agent designers do not need to keep track of the score they perceive other agents are giving them, but instead they measure the subjective utility they have received from other agents. And you know, it's really important that each node is left to maintain their own rankings of other peers with no obligation to report how or why these rankings have been determined. So everybody's kind of playing their own game. And the metagame is the result of that. And it's this weird second order cybernetic thing, which we often get lost in. But one of the really interesting points in your wiki, and it's perhaps like another good practical story to tell, which illustrates the features of the second order game, is that, you know, like you say that there were a portion of miners who wrote a modification to their node in order to combat another portion of miners who was using pooling software that this first portion of miners perceived as predatory. So like, I'm so fascinated by, like, how did they know, you know, if everybody is not kind of like forced to share their rankings or the way that they achieve those scores of others, how did they know what was going on? And where is the middle way between those two things?
Yeah, that's a really interesting thing. I mean, to your first point quickly, yeah, you can kind of see something very similar to AIIA at work in the normal world. Like, you have people ranking each other socially, and they're not at any obligation to tell each other how they're doing so or why. And indeed, there is no enforcement that they're all playing the same ranking system. So it's natural in that sense. Yeah, in this particular case, and I think this is the way it will. So the most malicious way to play the game is to not show people your ranking. As it happens now, if you say get stroke peers on an Arweave node, they will tell you how it's ranking things. But you don't need to, because you know how a node is acting to you, right? So Andy, if you send me the block header first every single time, I know that no matter what you purport your ranking system to be, I must be pretty close to the top, because I'm doing something right, because you're giving me the block before everyone else is giving me the block. Or we could see it another way and say, okay, well, at least Andy likes me more than Greg, because Greg is never giving me this header. Yeah, you can kind of think of it from that perspective as well. But in this particular case with HPool, this was quite interesting. Yeah, I mean, essentially HPool had just decided, well, let's just not share data. And the result was the rest of the network said, well, fine, we just won't share data with you then. And then they blocked HPool, and then there was a problem and they had to kind of resolve it. But yes, that's sort of how the consensus in the system works. Is quite elegant. It's quite like democratic in some way, but without enforcing steps where we all agree that the state is one thing. It's much more anarchistic than that, if that makes sense.
Mm-hmm. It absolutely does. One of my favorite sort of throwaway points is that anarchism, it doesn't mean no rules, it means no rulers. And it's in fact how the sort of majority of human civilization has taken place, particularly if you look at David Griever and David Wengrow, new book, The Dawn of Everything, wonderful. They're a big part of the kernel syllabus. And yeah, I'm very much in favor of that kind of, it is intuitive. And I think that we have, again, like, as I say, even in my own reading, we tend so often, particularly in our profession and in our more intellectual pursuits, to look for and then latch onto and grasp these sort of firm intellectual handholds like bandwidth or financial incentives or these kinds of things in order to understand systems. But those systems which actually more closely mimic ecological environments, and like one could speak about like a forest being like something like a democracy, right? But it's not a democracy in the sense that we've implemented. It's something very different. So Sam, I want to, as I say, we have taken over Michael's Yunzo, and it's really predominantly about sort of tokenomics more generally, and the intention of this conversation is to sort of move from AIIA itself and use it to illustrate what kinds of different mechanisms can be designed further up the stack, and some of the really interesting work that we're seeing emerge in this really adaptive network environment that is flexible and simple and takes its best learnings from both HTTP and BitTorrent is this notion of profit sharing tokens and profit sharing communities. So I wonder if you can just give us like a little bit of an overview of what these things are, where they came from, and my predominant question about profit sharing tokens is the ability to trade proportions of future profit from the assets by trading the profit sharing tokens itself. But we can get into that perhaps.
Yeah. Well, I think there's a nice linkage here, which is to say that conversation we just had to grasp all of the concepts there is pretty, not even the concepts we spoke about, but just to understand this concept in its full complexity is so difficult that it kind of leads directly to tokenomics, I would say, because essentially what we're doing is, I mean, in mechanism design is just the idea of programming human behavior to some extent or other, at least in the crowd, by changing the incentives in a game such that humans do it. You can go the AIIA route and you're like right next to, well, what are the things that drives the human? It's very messy. It's very, very, very complex to reason about properly. Or you can go one step back and say, okay, well, what's one thing that everyone wants? Mostly everyone wants, at least to some extent, money. Okay, so now if we have a token, which is some scarce resource and can be used as a medium of exchange, or exchanged for a medium of exchange, typically in the case of crypto, right? We all exchange the tokens for dollars at some point to use them to pay rent. Well, now you've simplified the system substantially, because you've got rid of all of the complexities of each of the individual humans and the things they really want and care about, and replaced it with, well, they're all just incentivized to make this number go up. And so now you can build game systems inside there that are still, frankly, pretty complex to build well put together mechanism designs, like even Bitcoin's which is, I would say, the base mechanism design of crypto. Even that is actually quite complex when you get into the edge cases. For example, I don't know if you guys have read the paper about what happens to Bitcoin when there's no, when there's no block reward anymore, or when the block reward falls substantially below the amount given out in fees. Well, the whole thing actually apparently theoretically becomes highly unstable, because you'd be incentivized, if you're a miner, to take blocks off the stack and start mining your own blocks, retaking those fees, and you might lose consensus. And so even something as simple as Bitcoin is still quite complex. Anyway, so putting that aside, so okay, now we're in the world of token design. Well, we noticed that on the web, there are all of these streams of revenue happening all over the place, like in every application, essentially. One way or another, there's a stream of revenue. And the way that the Web 2 economy is sort of worked is, well, you get the creators come along and they create a piece of content, The content drives engagement with the platforms. The platforms have some monetization system, like, for example, adverts, or maybe they offer the creator, in the case of like Bandcamp, to allow people to download the thing, and they pay a tip when they do so. It's kind of not really enforced because you can stream it on the website, but like whatever, lots of people do it anyway. Okay, and then this creates a revenue stream. It's kind of revenue streams everywhere, but from a financial point of view, this is pretty inefficient, because these revenue streams are not financializable, right? So if you are a farmer, and you know, you're sowing some seeds or what have you, you don't just wait for the seeds for the crop to grow, and you harvest and then you sell the crop. No, you actually sell a future on that. And if you're a founder of a company, you very frequently go to a VC and you say, hey, I'm going to sell you 10, 20% of this thing. Please give me some money. And then you use the money to make the thing grow faster, right? If you couldn't do that, it would be very tricky. And that's kind of the situation that creators are in. Like, they have to wait for the crops to actually, you know, reach maturity and then be harvested in order to get the value out of them, which doesn't really make all that much sense. So imagine again, like, you know, you're a new artist and you go to Bandcamp and you're like, hey, I'm going to publish my album, and like a few people are downloading it each day. Like, you're getting $15 a day, but to get enough to get like a new studio or a new synthesizer or whatever it takes, or whatever it is going to take you like months and months and months. Why does that have to be the case? It doesn't have to be the case. So we realized that there's this sort of generalized principle that you could apply across Web3 that we call a profit sharing token, which basically says, if you've got a revenue stream of any kind, just print a token. Have that token dictate where that revenue in the future, or profit, I mean, in this case, it really is profit because there's nothing being deducted from it, where that profit in the future is to go to. And so now if I'm that artist and I go to, actually someone on the network built a thing called Band Play, which I can't imagine, you can't guess where the namesake comes from. Anyway, unoriginal naming aside, the band play system is quite like Bandcamp, except that you get a profit sharing token for each album. And so when you release the album, you know, Andy's new album, I could be an investor and I'm like, oh, Andy's new album is selling pretty well. I'll buy 20% of it from Andy now. And so now Andy's got, you know, like 3 or 4 months worth of a profit come to him immediately. And now he can go buy that synthesizer or whatever it is and go make better quality music and take another album to market, which you can just see how this is more economically efficient. And it's the same across the whole stack. Like, why isn't that the case on YouTube? Why isn't it the case on in Play, you know, the Google Play Store, or on the Apple stores? Like, the web is almost, I was gonna say almost exclusively, I don't know if that's true. A large proportion of the web is made up of this model of creators create something on a platform that creates a revenue stream. The revenue stream slowly accrues to the creator. The platform takes a huge chunk of it. We can clearly make that more efficient. That is essentially what profit sharing tokens are all about.
Fascinating. The other aspects of profit sharing tokens, and by the way, my album rocks, and everybody should definitely get some profit sharing tokens because it's going to melt faces. But the other aspect of profit sharing tokens, as mentioned in some of the wiki pages, Sam, is also that they contribute to governance. And there is underneath these things the notion of a profit sharing community.
Well, that's kind of the other way around. So you can have a profit sharing token without there being a community. So for like Andy's album, there doesn't need to be any governance. But for an application, yeah, you can have a DAO more or less, with a few different distinctions maybe we can get into. But the DAO itself can have, well, the tokens in that DAO can be profit sharing tokens. And then you can have, you know, imagine you're building a decentralized medium. You can have it such that, you know, the user has to pay a small tip every time they publish a page, something basic like that. And of course, the owners of the profit sharing tokens in the profit sharing community can be distributed the reward proportionately to their ownership. Does that make sense?
Yes, Yes, it absolutely does. And I would, I'd love for you to just like dig a little bit further on the profit sharing communities themselves, right? Because like they do exist as these kind of contractual constructions in SmartWeave, and you know they're capable of sort of streaming micro dividends to the holders of profit sharing tokens. And I wonder if you can just talk to us a little bit about some of those mechanics as well as the capabilities of the SmartWeave as opposed to a smart contract on Ethereum, and what kinds of things differ there, and how that contributes in particular to what you think a community really is.
Ooh. Okay. Okay, we'll save the last question to last because it's sprawling. Okay, first, profit sharing communities. Yeah, they have some really interesting features that incentivize, and well, for starters, supposed to be associated with a permaweb app. For those that aren't really aware of permaweb app, the basic concept is that it's an application that runs permissionlessly and ownerlessly after launch. So you put it on the permaweb, it's a web app. So it's like, you know, got a front end and it's got GraphQL queries to the Arweave acting as essentially a database, and users write to the Arweave to store data in it. So it's a complete web app, but it's permanent and ownerless. Sometimes, so we think the trustlessness of those systems is actually one of the most important things. We don't think that just having a DAO attached to a web app is necessarily that much better than a company. It's the fact that you don't have to trust anyone that the service is going to change in the future, which is actually where a lot of the utility is derived from. Same with Bitcoin. You know, if Bitcoin was run by a DAO, we couldn't really trust that there were always going to be 21 million tokens. But the meme is Bitcoin is 21 million tokens, and so we can be confident no one will ever be able to properly fork the protocol to add tokens to it. Okay, so you have these applications, but occasionally there is a need for governance of some sort, like, you know, maybe it's content moderation if that's what you want to do, or maybe it's what goes on the homepage, what should be selected. Basic things like this. Well, SmartWeave is a way of essentially having smart contracts in JavaScript, which run locally on the user's computer. And this means that it's very, very easy to add them into web applications, like super, super easy. Yeah, and so you can use the governance mechanisms of a profit sharing community to kind of dictate how things in the application work. One interesting part, if we want to focus on the mechanism design here, because I think in normal DAOs, this is very, very poorly handled, is good governance incentives. So we do something with vote weighting in the typical profit sharing community contract, where you basically say the number of tokens you have multiplied by the time you're willing to stake them gives you your voting power. And then that is, of course, proportionate to everyone else that has voting power. And this means that if you are like a small time holder, but you are die hard attached to this project, then you get a bigger say than a larger holder that just wants to flip the tokens in like a month or something or less. And this is really interesting also because it interacts with the profit sharing elements here, right? So imagine you've staked your tokens for 4 years. Well, as soon as you do that, now the governance decisions you make directly affect the amount of profit that will accrue to you in micro dividends over that 4-year time span. So you are incentivized to perform good governance. I highlight this because I think in the traditional DAO structures, the good news about DAOs, they're programmable, so we can iterate very quickly on their structure and improve them. Bad news about DAOs is that the current crop that we have are not super well formulated. You could argue that they're just direct democracy companies. So you can, I won't name them, but like in the DeFi space, some of the really major protocols, you can just buy a bunch of tokens, vote on an issue, sell the tokens immediately. And the only use of the token is governance. And that's really dangerous because it means that you're not incentivized to govern the protocol in a way that is good for the protocol. You're actually incentivized to use the governance to find ways to extract value for yourself from the protocol. Example being DeFi protocols where you can vote to mint more of the tokens to reward owners, essentially for rewarding people for staking a specific token. Easy attack on this. And this was performed like half a dozen times, something like that, in the DeFi summer to winter period. Buy a bunch of a shitcoin, or maybe you've already got some, and buy a bunch of the governance token. Vote to mint new tokens in this good protocol to reward owners of the shitcoin for staking it. Now the price of that shitcoin has radically increased because it's gone from obscurity to everybody needs this in order to have the new big APR. Dump those tokens, dump the protocol's tokens, right? And now the attack is done. And is the protocol better off? Absolutely not. You've more or less stolen that capital. But of course, in a community where you have vote weights by the amount of time people are willing to stake in, then you can't really perform that kind of attack because you would be hurting yourself substantially. Like you might be able to get some money out of the shitcoin over here, but you will suffer substantially from the main pot, which you needed in order to perform the attack in the first place. Finally, to the question of what is a community, I think the widest net that encapsulates all of it is something like a group of people that are all to some degree focused on achieving a similar end, something like that. And in the case of a profit sharing community, there are actually, it's much tighter than that. If you are in a profit sharing community, you are incentivized by the profit created by the application associated with it. But yeah, what do you think, Andy?
It's a classic, fencing move. Just parlay it off and pass it on. I like it. Yeah, it's
no. I'm curious. It's a very difficult question to. I could say a lot of things I think it isn't, that in crypto we aren't always necessarily that clear, if you want, but I don't know, it would be helpful.
Yes, yeah, I think that's one of the ways that I've always really enjoyed of defining it is in the negative, but there are subtleties to this. So I've always loved David Griever's definition of a community as a group of people who are all slightly in debt to one another. This is kind of like the old anarchistic way of looking at it. If you look particularly in the Middle East, but many indigenous cultures, you would never give back a gift of exactly the same worth to what somebody had given you, because it's the ultimate insult. It means I am now done associating with you. I'd either give you something worth slightly more or slightly less, so that like there's the need to come back tomorrow and give me a chicken or an egg or a potato, whatever it is. There's like this constant transactional interest. So I really like that particular notion. It has to do also with the sense that like community is in some sense about willingness to bear a cost for someone else. That we often speak about in this like wonderful, fluffy belonging sense of, well, like, yeah, we're here for each other and support and emotional, and all of that is true, that those are the emergent effects of community. But what it's actually about is like, who are the people that you're willing to bear some burden for, bear some cost.
That's really interesting.
Connection it comes at a cost, as you know, in like bandwidth terms and then networking terms as well. There's a cost to connection, right?
Yeah. I was just thinking this brings us back to AIIA. Arguably, that is precisely how AIIA works, is that everyone is kind of slightly in debt to each other in this network of like who's done which favors for everyone else and how do they rank those over time. But that's just an analogy for real life, which I would say is, we call this karma sometimes, right? Like this vague sense that what comes around goes around is kind of expressed in these mechanisms.
Yeah, it's beautiful. I love the fact that you've called it karma in the recent wiki pages. That's what you're tending towards, because it does pinpoint this particular intuitive insight that I think sits at the heart of the Arweave network. And like one point that I do want to like just mention before kind of throwing it open is that, like often when we have these kinds of discussions, if you're not like that familiar with game theory, you're not that familiar with this particular kind of language and metaphor, it can seem like there's like this too easy link between like calling something a game and trivializing it, which is not at all what Sam or myself or anybody here is really doing. Like these ways of like stripping some of the complexity in order to get towards like simpler ways of looking at things that then engender their own incredibly like beautiful and complex games and spaces is like a truly wonderful thing to be engaged in. It's one of the things that I love most about mechanism design, and it leads to these incredible things like what Sam said earlier. He's like, is there a way of proving mathematically that human civilization is tending toward more pro-social behavior? Like that. Sorry, Sam, when you said that, I was just like, holy it's such a galaxy brain kind of comments. I just thought it was worth kind of highlighting again. But if there's any others who would like to sort of pose some questions, ask about either these really interesting profit sharing notions or some of the adaptive incentive design, please. We still have some minutes, and it's important to hear some other voices. Sid, I know that you were commenting in the chat, or anybody.
Yeah, seeing if there was anything.
Yeah, I mean, Paul and I have been using Arweave for a project that came out of kernel over the last 2 days, and it's our first time using Arweave, and we are just learning so much. So,
cool.
So yeah.
How's it going? Any feedback?
No, I mean, I haven't gone to the technical details of the yellow paper yet, but from a user perspective, yeah, like using the wallet was quite interesting. Like this AR Connect, then this Arweave, and getting all of it to work was initially a challenge, but yeah, it's all well documented. So
yeah, I think we're trying to improve that stuff a lot. We give away these free tokens to people on Twitter if they verify themselves. So because it's Sybil resistant, right?
Yeah.
The faucet, exactly. But I'll be frank, like someone on that team that has a very engineering focus built that system. And so they didn't. There's just a couple of things we can do to make it nicer for people that aren't really familiar with it. Like they build it for the very technical angle, which I think confuse people a little bit. First.
Yes, and if you're on this call and are hoping to experiment with Arweave, you have your own faucets over here. You can feel free just to send me a DM in Slack, and I will help you out. So because I've been seen as I'm in the process, in fact, of building a book and using Arweave to. This is why I'm so interested in like the Arweave and NFT conversation, because how it's currently structured as NFTs on Ethereum, which have the ability to change the guardian of these NFTs can change the token URI, and the URI currently points to a page stored on Arweave, which is just an HTML document that keeps each of the chapters, and so like the guardians of these NFTs can like change the chapter, because the whole idea is to try and illustrate how economic transaction and artistic expression are simultaneous in these kinds of environments. When you merge economics and language kind of inextricably in this sort of executable public adversarial environment, then all of a sudden, like some kind of transaction is simultaneously an artistic statement. It's really interesting ways to explore that. So perhaps we still have a few minutes. Perhaps you can tell us a little bit about some of the less obvious uses that you're looking forward to that are not just skeuomorphisms of like Twitter on Arweave, but like broader explorations of culture and sociality when we have a permaweb.
I think the critical thing that in the short term differentiates the permaweb from the centralized web, because of course the point of the permaweb is permanent, right? And so in 200 years, that's going to be a very different feeling than it is today, because when you put a piece of information into the permaweb today, the likelihood is it's still around on the centralized web, right? And so the archive takes time to mature. Essentially, that is already happening. It's been 3 years now, so we've got some pretty big chunks of history stored in there, like massive archive of first-hand, I'm not sure what you would call it, artifacts, essentially, from the Hong Kong protests for example, 2019. Yeah, huge archive of that stuff. So there is some of that is starting to emerge, but for now, I think what differentiates the permaweb from the centralized web is ownerlessness. Like once you put a piece of information into the permaweb, it doesn't go anywhere, no matter what the person that uploaded it wants to do either. And so this means that you can have spaces on the internet that are public and publicly owned and publicly controlled. Example would be decent.land. So basically building, it's kind of a little bit skeuomorphic. It's kind of like Reddit in a way, but each subreddit is its own profit sharing community. And to take part in the community, you have to buy some of the tokens and you stake them. And then you can, and everyone votes to elect moderators, and those moderators can be de-elected at any time. But also, when you ban a person, you slash their stake. Right? And so now the set of incentives that emerge from this are really, really interesting. You are incentivized not to be a nuisance because people will slash your stake. Okay, that's cool. So for a start, no more trolls because they lose money when they troll. Next, you're actually incentivized to make the community more desirable to be part of while you're a part of it, because of course your tokens are staked, right? And so when you get to the unstaking time, and it's yeah, you can liquidate those tokens. You want the value to be higher than it was before, and that's only going to happen if more people want to be part of the community. So that's pretty interesting. And then from the point of view of the founder of the community, the game is totally different. You start with all the tokens, and you give tokens to people as they contribute during the early days. So like being useful, frankly. But as you do so, again, the desirability of being part of the community rises, and so the token prices rise. And now suddenly, like building a great community on Reddit equivalent, could in fact be a viable model for living, which is pretty cool. And on top of this, there is no Reddit company that controls your community. Your community is self-governing and is autonomous unto itself, which is just something that you can never achieve, no matter how hard you tried on the centralized web.
Amazing. Do you have just a few more minutes, Sam? I know that we're coming to the top of the hour. Wonderful. There's a really incredible question from A. If you're willing to unmute yourself and ask it. If not, I can ask it for you. Sometimes microphones can be a problem. Okay, so A says, what about short-term optimization, even for mutual benefit, being antithetical to long-term optimization? It's especially dangerous when mixed with herd behavior. There might be something about the ease of contentious forking that lends value to decentralized communities that's far less prevalent in Web3 than, say, like Bitcoin.
Yeah, that's interesting. I think with AIIA, the incentives are longer term enough because you really have to invest in setting up the system, in setting up an Arweave miner. So you have it's almost like stake in some sense, like fuzzy kind of stake. But yeah, I agree that the longer you could get people staked in, the better the AIIA game is going to work for producing long-term pro-social outcomes, for sure. There's an interesting question, when you tie up, again, think what's happening in the real world around us. We have quite long time horizons because we occupy the environment for like, I was going to say 60 years, hopefully a bit longer than 60 years, 80, 90 years, whatever it is. Yeah, so we really have a vested stake in it. The longer that you can do that, the more you're going to get that, yeah, longer term time horizon for sure. It's an interesting point.
Yeah, and there are also some wonderful sentences to go and find in the yellow paper there, which highlight the fact that you do have this interesting feature of AIIA that's it's one of the features that I like the most about the yellow paper is that 3 of the kind of problems of this approach are outlined, and one of these is that indeed like the short-term signaling costs can be quite high for those who are like after a loving and kind world that are operating in a capitalistic and greedy system, which is a wonderful way of explaining it. Sid also asks,
yeah,
sorry, yeah.
Well, I was just saying yes, but the point of our finding, at least, it seems to be that, that yes, there is a cost. I would actually say that it's but you should still be incentivized to do it. It should still eventually get you back more than you give out, essentially. But there is an interesting flaw, or not necessarily a flaw, but like a non-trivial edge case, which is if the environment is shifting too quickly, then this very slow movement towards the pro-social behavior in the environment, because that's how we outlined it originally in the yellow paper. It's basically, well, the internet looks like this today, but in the 200 years, God knows what the internet looks like. It's not going to be the same thing. So you need to find the pro-social behavior in the new environment. But there's this, so we know that you're incentivized to incentivize others to do the pro-social thing as you see in the biases, and the net effect of people's biases will come forth. But it will do so pretty slowly. And if the environment is changing too quickly, then you can come to this situation where you just don't come to consensus about the right things to do. But that's a different conversation, maybe.
Yes. When we run the full models in our next conversation, we'll get there.
Why not?
There's a wonderful question from Sid in this. He says, how do you get out of the skeuomorphic mindset when you're building transformative tools?
Spend a lot of time walking, like like don't. Well, the question is how to think creatively. Don't let yourself get too stuck in the present, I guess. One thing I've learned about business over the time that we've been building Arweave is that you kind of succeed or fail based on your ability to do things differently. So there's an interesting thing that you're kind of, the crowd is always going in one direction. And that there's a general sense of pull towards that direction. But the thing is that if you just do what everyone else will do, what everyone else does, you will inevitably fail, because it's impossible to compete against the crowd at what the crowd is doing. And even if you did, Peter Thiel has a really mind-blowing chapter in 0 to 1 about this. If you haven't read it already, you definitely should, about competition. It's called Competition is for Losers, which is a pretty obnoxious, brash title, but like the chapter is incredible, because basically what he's saying is competition in capitalist societies is great for the society and is terrible for the company and the founders and the investors of that company. Because what happens is that people compete to get the profit margins down to the minimal viable amount. And when they do so, of course, that's bad for the company. So, but of course, it's good for society, right? Which is a kind of interesting dichotomy. But I would say that, like, if you want to build something, if you're founding something, you want to think almost from first principles most of the time. Don't just do what the crowd is doing. Deliberately do things that you think the crowd has missed something. It's hard to tell sometimes, but actually go ask them, like, hey, why aren't you doing this? Why is it that you think this is the right idea? And then if you don't get satisfactory answers, that's okay. Just go do it yourself and see if it works out. Because unless you do those things that are weird and out on the fringes, there is no differentiation, and you will just compete to death with everyone else. Anyway.
Amazing answer. Be weird, go on lots of walks. Sid has got both of those, I think.
Thank you.
I know.
Thank you, Sam.
I know Vienna has a question, perhaps.
Yes.
We might end there.
Yeah, it'd be good to get some more context on this if you could unmute, or we can just go from the text version if you want.
Sure. So first of all, amazing. Like it felt okay. I just loved what you were saying. It felt like it reminded me a lot of what we were discussing at Economic Space Agency back then. But then, like, so there's this model that I often thought about, like, as, using the whole, like, financial model to try to address, like, a pro-social outcome. Like, in this case, I'm thinking about, like, climate, like, change mitigation. Now, and then there's also things like I'm curious about offer networks, like, you know, kidney exchange paired markets. And I wonder if you have ran like any, like when you were saying like I had it encoded as verification towards like pro-social behaviors. If you have ran numbers on like that model versus that model, but then what I'm really trying to get at is like, you know, how should we get to a place where if I care about like quote unquote temperature being one of the way that we know things are
annealing. I thought you meant the physics process of annealing, which is also relevant for what it's worth. But okay, yeah, now I'm tuned in, right? Temperature, climate. Okay, yeah, how do we get towards creating?
Can I just mention one thing? My definition
yes,
for temperature and thermodynamics is definitely much more expanded than the standard definition. But I'll just start from there. Yep.
Oh, so hold on. Did you mean annealing as in thermodynamics, or did you mean like the temperature of the climate? Both are interesting conversations and kind of
in my own mind, the annealing starts from the mind and expands also to temperature, but I'll just stick with people's standard definition for now. Yes. Because neural annealing is real for me. So
yeah, exactly.
And then physical annealing.
In AIIA, it's definitely clear that there is some process like annealing towards the prosocial behavior. Like over time, it's not like the crowd is going to pick the single thing and then move towards the single thing all in unison. It's actually much fuzzier than that. And it, sure enough, I would expect would have an annealing pattern to it if you play it out. Now, to the environment, that's an interesting question. I think it fits within the framework, right? And we see it in the world around us again. Like people are actually, despite the weak incentive, relatively speaking, on a personal level, like we're probably all gonna be okay for the rest of our lifetimes if we do nothing about climate change personally. But we can very clearly see that as a group, something's got to be done. And sure enough, people are actually working to incentivize others to do the prosocial behavior. In fact, I think that I've never seen a more perfect example of it. Like they go rally to push people to incentivize other people to act in the way that is prosocial, in this case, you know, not heating up the climate too quickly. I think it's just a natural part of the game. The weird thing about the AIIA game is it is the meta game of life in some sense. So what I was fuzzily trying to talk about at the beginning, what got us into it was this analysis of like the different. We think that communism and capitalism are purely mechanism designs for organizing society. The people that made them didn't have words for it to describe it like that, but it's pretty clearly just a game for organizing humans. And there are lots of games and they have their own, you know, benefits and negatives. But the strange part is that when you abstract yourself from your life and the life of the society around you, see very clearly, oh, actually nothing, there is no consensus. Nothing is enforcing these games. It's only the people inside it. And that was what led us down this path, was like, wait, doesn't it look like this is tending towards prosocial behavior? And then well, you know, the rest is, I guess, what we kind of presented earlier.
It's honestly, I mean, we can do another 3 hours on just the people inside it. You know, people at layer zero, the way in which narrative controls so much of how we shape games, the language of the game, not just the theory of it, the nature of the impulse toward coercion. So many of these things are many that we could explore, in addition to the like really interesting features of Arweave, which we'll have to have you back to talk about, like the fact that these JavaScript like contracts in SmartWeave are local and not kind of you know, part of necessarily like the wider consensus, which is just another like very wonderfully interesting and radically different approach to how we might play these kinds of games from where you know currently see these consensus enforced protocols which we're using at the moment. So Sam, thank you so much. It's such a pleasure and a joy talking with you. We get to explore.
Thank you so much for having back the deep and interesting conversations. I hope I got the points across correctly. They're not trivial to communicate. I'm afraid I don't have the perfect language for it.
But it's wonderful. This is the point of kernel, is that we get to play infinite games with one another, which are about repeat interactions, win-win games, and low miscommunication. So we keep on playing these win-win games with one another, and we'll eventually come up with wonderful language to describe all of the crazy stuff you're doing. And sort of see where we land up. I deeply appreciate your time and your expertise. It's truly a privilege and an honor. So thank you.
Likewise. Thanks for the opportunity to speak, everyone. It's been fun.
Yeah. Enjoy the rest of your day.
Thanks, Sam.
Everybody.
Yeah, everyone.
Michael, thank you so much for giving us your Yunso.
This is great.
You're the best.
Great. Super. Couldn't have possibly done better. Thank you so much.
You're the MVP, Michael.
I assume that means minimum viable